Hello, everyone, and I want to thank the organizers today for inviting me to present. I am very excited to talk to you about how government, industry, and academia can work together to improve food safety. So I'm just going to jump right into it. But first of all, I do want to share my disclosure slide. Just about every faculty member has some contact with industry and other groups, so here you can see a list of those who have given me grant and research support, some advisory boards and consulting roles I have, as well as a stockholder situation and my employer of Texas Tech University. None of these entities, aside from Texas Tech, has been involved in any of the research that I have in presenting today. But as we know, all of our experiences in life inform our opinions and where we go with the rest of our day or the week or our life, really. All right, with that, to get into the actual meat and potatoes of the presentation, I want to begin with just giving you a little bit about my background, since I'm talking about how industry, academia, and government can work together. So I recently left my position as Undersecretary of Food Safety, where I served at the USDA from 2019 to 2021. And in this role, I was responsible to oversee the activities of the Food Safety Inspection Service and to make sure the food in the U.S. was safe. It included the oversight of imports and exports. And in this role, I did serve as the highest ranking food safety official in the United States. Now, prior to that, I spent my entire career in academia. I began my career at the University of Nebraska as a professor and extension food safety specialist, working very closely with the industry. And then after about 5 years, I came to Texas Tech University, and I also returned there after my role was over in Washington, D.C. Now, in both of these roles, I have conducted very applied research for the industry. So I have the government experience, I have the academic experience, and while I haven't worked in the industry, all of the data that I have managed, generated, has either been done in an industry setting or I've worked directly with them to utilize their data. So I really think I have a well-rounded perspective. From this experience, I really think that as we look at the different types of data that are out there related to food safety, that if we could put together the three entities, academia, industry, and government, take that data, put it together, and be very collaborative with it, I really think we could move the bar forward to improve food safety, not only in the US, but all over the world. So to give you a little bit of insight from my perspective on the different types of data and what we see when we look at the different entities, first of all, I'll start with industry. The industry has very strong scientists across the board. We have PhD scientists, we have those who have been in academia or been in government and come to industry. So I'm going to say very consistently that all these groups have very strong scientists. Now, the data they generate is going to be very focused on application. And what I mean by that is how can it be applied to their particular company or processing space to make the food safer or to monitor it, to make sure that they're operating safely and those types of things. Mostly, they will be collecting data on a daily basis and using it to inform decisions that are both food safety driven as well as those to best benefit the business. Now, they are generally reluctant to share their data. Most of it is not peer reviewed and put out in a peer reviewed publication. People don't want others to know what goes on inside of a private business. It could be proprietary and give them some type of competitive edge. And they certainly don't share everything with the government, because once you share something with the government, whether it be USDA or FDA or other agencies, it becomes a matter of public record. And then it's foiable and someone could get that, write a negative story, and have a detrimental impact on your business. Then we have academia. Again, we have strong scientists and academics, but we are really focused in academia on publication. And I say this in that we really do hypothesis-driven research. We're usually training a graduate student, a master's student, a PhD. Our goal is going to be get those students trained, support our hypothesis with statistically sound research and data, and then move that forward to the realm of peer-reviewed publication. So it's a different perspective, still food safety driven if you're working in the area of food safety, but within academia, we don't do a really good job of sharing the data that we have with the government or even with industry. I just thought, whenever I was a scientist and we put out a publication on the effectiveness of an intervention in a processing plant, I was like, well, the government will see this, or, FSIS is surely aware of the work we're doing, or the industry is surely aware of the work we're doing, but we don't communicate that back to those entities. I can tell you, people in the government are just like those in any other realm. They're busy. They're not out actively seeking all the new data and publications that are out there. So really, we need to do a better job in academia to take this to government so they can utilize the data that we have. And then finally, we have government. Again, very strong scientist in the government. My role at FSIS was just wonderful because I was surrounded by, I always called them my dream team of scientists, because not only did we have microbiologists, we had those with expertise in risk assessment and statistics and epidemiology and modeling. And then we had DBM PhDs with Masters of Public Health who knew about outbreak investigation. So I had everyone there at my fingertips. There's a very strong team of scientists at the agency, and I miss them very much. So if any of you are on this presentation and watching, I want to say hello to you. But back to the story here. The data that is generated in government is sometimes public, but oftentimes it's not public. A lot of times data are generated to determine where an outbreak might be occurring, where there might be a problem in industry, to inform decisions related to developing a new baseline. So this data doesn't necessarily become public, but the objective of a lot of the data that's collected is really to inform policy and rulemaking. And once you get to that point, the data do become public, to where it can be very much dissected, whether it be subjected to a peer review internally or externally, and then everything is very much put out there, laid bare for the public to comment. So you're not only getting reviewed by a peer panel, you're getting reviewed by anyone and everyone out there in the public space. So that becomes very difficult. Now, oftentimes the government doesn't pull on academia or academic data. Sometimes they do, but not always if they're unaware of it, or data from the industry to make those decisions related to public policy. So if you look at across these three realms, we have common themes there. We have strong scientists, we have a focus on food safety, and we have data. But we all have different types of data that we really need to take and utilize collaboratively and collectively to make decisions. So what's missing? Communication and collaboration among the three entities to really make an impact on food safety. Now, to really emphasize this point, I want to just highlight some opportunities that I have seen from all three angles that could be opportunities for collaboration, and that's addressing salmonella from a public policy and developing new policy standpoint. I think we had really good data at the agency and as we were trying to set performance standards, but as things move quickly, more data are available, and I'm going to show you how this some of the data developed in academia using an industry partner could be very helpful. So a lot of times the data, like I've already said, in industry is proprietary. And so they might be monitoring salmonella when it comes to performance standards. Usually they're taking samples every single day, and the samples are taking might be taken at multiple points in the process and multiple times a day. The government, but the industry data is only from their particular company or industry where they are. The government has the opportunity to take data from all the establishments and does take data from all the establishments. So their perspective is very broad when it comes to salmonella analysis and establishing those baselines. But at this time, they're only taking one sample from each establishment a day. In theory, it's actually about 50 samples a year. So you might get skipped a week or two here and there. And then in academia, when we go into processing plants, we're taking data, but it is usually to validate an intervention in a plant setting, or to determine process control, or to biomap the pathogen through the system. So again, it's only in one particular operation, maybe a couple if the company has multiple establishments, but it's really to achieve one objective. So you go in, get the data, prove or disprove your hypothesis, and then you're out and gone. So let's circle back to the government performance standards. So when performance standards are developed, and this is a very simplified viewpoint because it's actually super complicated with tons of formula and modeling and everything else. But what will happen is, first of all, there needs to be a baseline in whatever commodity. So for example, currently there are salmonella performance standards for whole chicken carcasses and turkey, and then for parts, chicken parts, and then also for comminuted or ground product. Before they could get that performance standard, a baseline across the country had to be established. That takes a lot of time to get that over a year's time, to analyze it, make sure you're representing all plants, the sizes, the amount produced per plant, and all of those different entities. Then the human illness data from the CDC is superimposed with this, put in the formulas. How many salmonella outbreaks per year are we seeing, and how many of those are actually attributed to poultry or specifically chicken? You want to get that data. Then we take our Healthy People 2030, obviously it was Healthy People 2020 goals that we did not meet, and we put that in the formula of performance standards. And the goal is to reduce salmonella in the population by 30%, because those are our HP 2030 goals. And then we determine how much of the current baseline do we need to reduce in poultry to meet these HP 2030 goals. It's very complicated, but that's a process that we go through. And this is why it took so long to get some of these performance standards out. Then it has to go out for public comment, which is where we are with our beef and our chicken Campylobacter performance standards. So that's how it's done in the government, taking only their data. I'm going to talk about a collaborative approach that would be very helpful. So here you see a line of chicken carcasses, obviously, and I want to thank my colleague, Dr. Marco Sanchez, who developed this slide and also works collaborative with me on many of these projects we're talking about. So there are, I think, 17 carcasses here represented, and we're going to pretend that 4 of these, represented by the red plus mark, are positive for salmonella. That is the current standard for performance standards, positive or negative. Now, this one, you'll see, it only, if you count the number of salmonella, we have 1 CFU per mil if we do a rinse. Over here, we have 1 million CFU per mil if we do a rinse. So which one has the highest risk to make it cause illness? Well, it doesn't take rocket science to figure that out. Obviously, 1 million is more risky. So we go to this one. It has 1,000 CFU per mil, and this one has 10. So there's lots of variability there. So if you see, 4 of our 18 carcasses are positive for salmonella, so we have a 22% positive rate. This would not be passing the performance standard, but we actually only have 1 that is above 4 logs. where did we pick 4 logs? This is a hazard versus risk evaluation. So let's look at this graph. This graph was taken and it was developed by the WHO to determine how many salmonella cells must we have to actually cause human illness. This is the bottom line assessment of this evaluation. And what we find here is really you need 4 logs or 10,000 cells to cause human illnesses. So go back to the poultry carcasses, even though they were testing positive, all but 1 were less than the risky carcasses that would be above 10,000 cells. So let's put this into context of real world data. So we're doing a lot of biomapping in poultry plants and in pork plants to determine what not only the salmonella baselines, what's positive, what's negative, but actually doing quantitative analysis. Back in December and January, the BAC system, Hygiena, was approved for quantitative analysis and determination, excuse me, they were approved to quantify salmonella using a rapid method. So let's see what we found. I'm going to start with the percentage positive that we're finding in this poultry operation. You can see coming into the process, we have 86.7, almost 90% of those are positive. Going through the process, they stay positive. As you get down to pre-chilling and post-chilling, after chilling, only 35% are positive. So these are the percentage positives, it's going down. But let's get to the parts. Here we go. It's popped back up to where we had live animal receiving. So this kind of tells a story that our dips, our wings are as bad as our incoming live animals. After the dip, it's down to 58. Here we have our tenders, it's around 78, and then their dips and it gets down to 36%. So this is a percentage positive. Now what we're going to add to this is the quantitative data, which tells a completely different story. We still have our line here representing the percentage positives. You can see though on our y-axis, we have almost a 4 log incoming load of salmonella when we count it. At rehanging, it's down just a bit. The solid bar here represents the average, whereas the entire bar represents the standard error. And then at post-evisceration, it's down to less than half a log. And by the time we get to chilling, even though we have almost 50% of those carcasses positive, it's down to numbers we can't even quantify. Go back to that risk association by the WHO. These are low risk products. After chilling, 35% positive, still they're not quantifiable. Now let's look at that wing sample. 88% are positive, which makes it look almost as bad as it is at incoming receiving. However, compare the quantitative loads. We have it here around, actually the average is around 3. Here, it's at half a log. The risk is much lower, even though the percentage positive is very similar to what we saw coming in. After dipping, non-quantifiable, similar trend for the tenders before and after dipping. So what we're doing in only using the data that give the percentage positive is that we're putting a lot of time and effort into these samples that are causing us not to pass performance standards because we have a high percentage positive. It may move us from category 1 to 2 or 2 to 3, but the reality is it's a low risk. If we start using quantitative data, it can help us focus where our true issues are and where we have the risk, which is really back over here where we're getting the high numbers. And we can put a lot of effort there, reduce the incoming load, and then that's going to trickle down to reducing the prevalence in the other products. So again, this is a hazard versus risk situation. If we could take this approach in the government and use this to make decisions, to establish new performance standards, it would really keep us from taking a shotgun approach at the industry level to controlling the pathogens. Many in industry are using this to divert product. They're using what they'll call a LOD 10. So if it's above 10 cells of salmonella, they'll divert it to cooking. So it's the concept has already caught on in industry. We're getting data in academia. We have started publishing this data. Now we really need to bring government on board to finish up the circle, to drive this, to make decisions that are keeping up with the data and also the technology that's available. Now, there are still a lot of research needs. We have one company out now that has AOAC approval for the enumeration techniques. We need to keep moving that forward. The agency needs to evaluate this to see if it is fit for purpose in their operation, if it actually works when you only take one sample a week, or if we need more data to inform that. So there are some data needs associated with that. Also, we need to take a really hard look at our serotypes versus whole genome sequencing. A lot of our serotypes, there is a petition before the agency now asking for particular serotypes to be declared an adulterant. That really is much too narrow of an approach. These serotypes that cause human illness are always changing, especially as the industry pivots in the poultry industry to use vaccines to target particular serotypes. We'll have other ones take their place. So I really think we need to take all the data that's being generated on whole genome sequencing by the CDC, FDA, USDA agencies and look at the pathogenicity. Let's look for the pathogenicity genes that actually are related to human illness, and we can further pull out our salmonella that are the most concern and are causing the human illness outbreaks. That's where we're really going to move the bar from 30 to get a reduction of 30% illnesses in the population. There are many groups working on this, and I look forward to seeing the outcome of a lot of their data and their analysis that they're generating. Also, interventions. I think about 20 years ago, we started using interventions in the beef industry. It trickled into poultry industry, but that approach has really not changed a lot over the years. It's been an approach of add another intervention, increase concentration. There's been a lack of innovation to look at new technologies, and also to be strategic in how you use those technologies. It's just like I showed you in the poultry data. If you're going to be strategic, I'm not saying take away all the interventions on the part side. Definitely, we need them there, but we really need to focus efforts to bring down those pathogen numbers in the front end of the process. When you have that information, you can be very strategic in your decision making to actually impact food safety. And then as we move further along, and as you again saw from the poultry data, there has to be an emphasis on pre-harvest. This isn't just for poultry, this goes to beef, this goes to pork. We know that pathogens originate on the farm. I'm not saying we're gonna eliminate them on the farm. I'm not saying I'm an advocate of regulation on the farm, because I'm not. I think it would be too difficult to regulate on the farm. But I do think there should be an expectation for certain pathogen loads coming into the process. So with that, I'm going to just briefly give you an overview of some of the doors that were opened by the government while I was there, and some of the things that are ongoing, because some of the examples I've given you are things that the industry is doing and that is going on in academia, but I really want to put an end with a positive note on some of the things that are going on at the government level to open doors so we can have this collaboration and cooperation. I can tell you the scientists at the agency very much want to collaborate and cooperate, but there have to be mechanisms available to bring the data into the government agency without a fear of having some kind of harm to a business. So one of the things that was developed was a FSIS ORISE fellowship for graduate students. And in this process, what we did was set aside money for fellowships for graduate students who were working on projects that were directly related to the agency's research needs. And we had many applicants. We had a panel of our scientific team who went in and evaluated these, and we were able to start three uh, fellows before I left the agency. This brings those from academia into the agency. These fellows are going to be interacting with our scientists. So it also opens the door to bring in these individuals into the agency and also to provide data to inform decisions within the government. Something else that occurred was the ability for companies to come in and ask for a period of time in their operation to test new intervention technologies. I cannot tell you how many times I would have someone come in and say the agency is a hurdle for implementation of new technologies because no one will test a new technology if they're already in, say, category 1, because if they test it and it doesn't work well in their system, or if they have to do some troubleshooting and they get a salmonella positive, it will count against them in performance standards, perhaps move them into a different category, and then that has an economic impact. So in this case, what can happen is that a facility or establishment can ask for a 30-day window to bring in a new technology. They still have to meet salmonella requirements. They have to do their own testing, but it won't count against them in terms of performance standards. So this opens the door to the implementation of new technologies. And then something that is really exciting and moving forward is expanding the accreditation process that the agency has from not only chemical testing, but to microbial testing in labs. And labs can get accredited by FSIS. And then when this happens, the data that those labs generate, we know that they meet the standards that are upheld in the FSIS labs, and it really opens the door for that industry data to be able to be utilized to make decisions in the agency, whether it be for baselines, for performance standards, or for whatever activities and rulemaking processes or policies that the agency is moving to next. So it's a very good process, and I really look forward to this happening so we can have more collaboration and cooperation with industry, government, and academia. So just to wrap this up, I think it's very important for the three entities to work together. All of these different entities generate different types of data with different types of objectives, all of which are very important. But if we can share that data, it really just helps us make better informed decisions to impact the safety of the final product and also to protect the public and to reduce the foodborne illnesses that occur in our country every single day. Now, I used poultry as an example. This example is not exclusive to meat and poultry. It can expand out to all of our FDA products. Many of the examples are the same. So I am definitely not just saying that this is a good approach for USDA. It can also expand over into FDA as well. So with that, I very much thank you for your time and attention, and I will be happy to answer any questions and have any discussion that you would like to have.